Hello students, this is Dilip Udhani. Today I will teach you some basic properties of Laplace transform. First is linearity, then after first shifting theorem, and finally second shifting theorem and problems related to these properties. So first of all we will take linearity. If Laplace of f1t is f1s and Laplace of f2t is f2s, then Laplace of a f1 of t plus b f2 of t, that is equals to a constant as it is and Laplace of f1t, and Laplace of f1t is f1s plus b constant as it is into Laplace of f2 of t, and Laplace of f2 of t, that is f2 of s, right? Where a and b are constant values. Now we will see the proof of this linearity principle with the help of fundamental definition of Laplace transform. So Laplace of f of t, that is integration from 0 to infinite e raised to minus st ft dt. Now we will replace f of t by a f1t plus b f2t. So that is equals to integration from 0 to infinite e raised to minus st ft is a f1t plus b f2t. Now we will multiply e raised to minus st by this function and will separate the integration, right? So a constant value as it is, integration from 0 to infinite e raised to minus st f1t dt plus b constant value, integration of 0 to infinite e raised to minus st f2 dt, right? And now this is nothing but f1s. This is Laplace of f1t, and Laplace of f1t is f1s and a as it is. Similarly, plus b as it is. This is nothing but Laplace of f2t and Laplace of f2t, that is f2s. Okay. Now we will see examples related to this topic. Example number 1, we have to find out the Laplace transform of this function, that is 2t raised to 3 plus e raised to minus 2t plus t raised to 4 by 3. So Laplace of this whole function. Now we will apply principle of linearity, that is 2 constant as it is, Laplace of t cubed plus Laplace of e raised to minus 2t plus Laplace of t raised to 4 by 3. Now 2 as it is, and Laplace of t raised to n, that is n factorial over s raised to n plus 1. So replace n by 3, so it is 3 factorial over s raised to 3 plus 1 plus Laplace of e raised to minus et, answer is 1 over s plus e. So Laplace of e raised to minus 2t is 1 over s plus 2 plus Laplace of t raised to n, if n is in fraction, that is gamma n plus 1 over s raised to n plus 1. So replace n by 4 by 3. So it is gamma 4 by 3 plus 1 over s raised to 4 by 3 plus 1. Now value of 3 factorial is 6. 6 into 2 is 12 and divide by s raised to 4 plus 1 over s plus 2. Now this is gamma 4 by 3 plus 1, and we have one formula, that is gamma n plus 1 equals to n into gamma n. So applying this formula on this function gamma 4 by 3 plus 1, it will become 4 by 3 into gamma 4 by 3. So we have replaced gamma 4 by 3 plus 1 by 4 by 3 into gamma 4 by 3 and divide by s raised to 7 by 3. Now this 4 by 3 as it is, and gamma 4 by 3, that is 1 by 3 into gamma 1 by 3. Again we have applied this formula, that is gamma n plus 1 equals to n into gamma n. Now this function as it is, 1 over s plus 2 as it is, 4 and 4 and 3 3s are 9, and gamma 1 by 3 as it is, and divided by s raised to 7 by 3. Now we will see second example. Find the Laplace transform of 100 raised to t plus 2t raised to 10 plus sine 10t. So Laplace of this whole function, that is equals to Laplace of 100 raised to t plus 2 constant as it is, Laplace of t raised to 10 plus Laplace of sine 10t. Now we will write down 100 raised to t as e raised to log 100 raised to t to base e plus 2 as it is, and this is Laplace of t raised to 10 plus Laplace of sine 10t. Now applying the formula of logarithm, that is log 100 raised to t will become t into log 100 to base e. Now on this function we will apply the formula of Laplace of e raised to at, and a is log 100 to base e. So it is 1 over s minus a, and a is logarithm of 100 to base e. So Laplace of e raised to log 100 to base e into t, answer is 1 over s minus log 100 to base e, plus as it is 2 as it is, and Laplace of t raised to 10 according to the formula Laplace of t raised to n, that is n factorial over s raised to n plus 1. So replacing n by 10, so it is 10 factorial over s raised to 11, and Laplace of sin at, answer is a over s square plus a square, and in this case the value of a is 10, so replacing a by 10, answer is 10 over s square plus 100. Okay, now we will see example number 3. We have to find out the Laplace transform of sin 2t into sin 3t. Now you can see that this is not in a standard form. So first of all we have to convert it into the standard form. So Laplace of sin 2t into sin 3t. What we have done over here, we have multiplied these two multiplication of sine functions by minus 2 and divided it by minus 2. Now we have formula of minus 2 sin 2t sin 3t, that is cosine of phi t minus cosine of minus t. We have applied the formula of minus 2 sine alpha sine beta, that is cosine of alpha plus beta minus cosine of alpha minus beta. Here alpha is 2t and beta is 3t, so it will become cosine of 2t plus 3t, answer is cosine of phi t, minus cosine of alpha minus beta, that is 2t minus 3t, so answer is minus t. And all of you know that cos is an even function, so cosine of minus t will become cos t, and this cos phi t and minus sine and minus 1 by 2 as it is. Now Laplace of cos phi t minus Laplace of cos t. Now Laplace of cos et, answer is s over s square plus a square. So Laplace of cos phi t, answer is s over s square plus 25, minus Laplace of cos 1t, that is s over s square plus 1. Now we have to simplify this function. So the LCM is s squared plus 25 and s square plus 1. Now multiplying this s by s square plus 1. So the result is s into s square s cube plus s into 1s. Then after minus s into s square minus s cube, and plus minus is minus 25 into s, answer is 25s. So plus s cube and minus s cube will cancel out. Plus 1 is minus 25s, answer is minus 24s, and divided by this function will be as it is. And minus minus is plus, divide 24 by 2, result is 12s, and divided by s square plus 25 into bracket s square plus 1. So this is the final answer. Okay, now we will see example number 4. Find the Laplace transform of sin square 3t. Now you can see that again this is not in a standard form. So we will apply the formula of sin square at, and the formula of sin square at is 1 minus cos 2at by 2. So Laplace of sin square 3t, that is Laplace of 1 minus cos 60 by 2. Now we will apply Laplace on 1 and cos 60, and this 2 is a constant value. So 1 by 2 as it is, and Laplace of 1 minus Laplace of cos 60. Laplace of 1 is 1 upon s, and minus Laplace of cos 80, answer is s over s square plus a square, and a is 6, so 6 square is 36. Now we will simplify this function. We will find out LCM, and that is s and s square plus 36. So multiplying 1 by s square plus 36, and after minus multiplying this s by this s, so the result is s square. Now s square and s square will cancel out. 36 by 2, answer is 18, and divided by s into bracket s square plus 36. Now example number 5. we have to find out the Laplace transform of sine cube 2t. Now you can see again that this is not in a standard form. So we will apply the formula of sine 3 theta. The formula of sine 3 theta is 3 sine theta minus 4 sine cube theta. So making the subject of 4 sine cube theta, so that is 4 sine cube theta equals to 3 sine theta minus sine 3 theta. So sine cube theta, that is equals to 1 by 4 into bracket 3 sine theta minus sine 3 theta. But we have to find out sine cube 2t. So what we will do, we will just replace theta by 2t. So we have sine cube 2t equals to 1 upon 4 3 sine 2t minus 2t into 3, answer is 60. So it will become minus sine 60. Now Laplace of sine cube 2t, that is nothing but Laplace of this whole function, and 1 by 4 is a constant value, that will be as it is, and 3 is again a constant value multiplied by Laplace of sine 2t minus Laplace of sine 60. Now Laplace of sine 80, that is a over s square plus a square, this 3 as it is, and a is 2 divided by s square plus 2 square, and 2 square is 4. And after minus Laplace of sine 60, that is a over s square plus a square, and a is 6 divided by s square plus 6 square, and 6 square is 36. Now 3 2 is 6, and this is again 6. So taking 6 common, so it will become 6 by 4 into bracket 1 over s square plus 4 minus 1 over s square plus 36. Now we will find out LCM, and that is s square plus 4 and s square plus 36. So s square plus 4 and s square plus 36 will be as it is in the denominator. Now multiply 1 by s square plus 36, result is s square plus 36, and multiply minus 1 by s square plus 4, result is minus s square minus 4. Now s square will cancel out, and 36 minus 4, answer is 32. Now this divide this 32 by 2, the result is 16, and multiply 16 by 3, answer is 48. So 48 by s square plus 4 into bracket s square plus 36, this is the final answer. And you can simplify 6 by 4 as well, that is 3 by 2. So this is the final answer, that is 48 by s square plus 4 into bracket s square plus 36. Okay, now we will see second property, that is first shifting theorem. If Laplace of ft equals to f of s, then Laplace of e raised to minus at f of t. The result is f of s plus a. What you have to do? You have to just replace s by s plus a in f of s. If you have to find out Laplace of e raised to minus at f of t, right? Now we will see first of all the proof of first shifting theorem with the help of fundamental definition of Laplace transform. So Laplace of f of t, that is equals to integration from 0 to infinite e raised to minus st f of t dt, and we have to find out Laplace transform of e raised to minus at f of t. So what we will do, we will just replace f of t by e raised to minus at f of t. This is equals to integration from 0 to infinite e raised to minus st, and f of t is e raised to minus at into f of t dt. Now e raised to minus st into e raised to minus at, it will become e raised to minus of s plus a t into f of t dt. Now you can see that integration from 0 to infinite e raised to minus st f of t dt, that is Laplace of ft, and Laplace of f of t, that is nothing but f of s. So this integration is f of s. If you will find s over here and f of t over here, and the limit of integration is from 0 to infinite, then it will become f of s. Now similarly, you can see this result. In place of s we have s plus a. So definitely this whole integration will become f of s plus a. So we have Laplace of e raised to minus at f of t, that is equals to function of s plus a. Similarly, we can find out Laplace of e raised to at into f of t, that is equals to f of s minus a. This is first shifting theorem. Now we will see some examples related to this. Example number 1. Find the Laplace transform of this function e raised to minus 3t into bracket 2 cosine of phi t minus 3 sine phi t. Whenever you find e raised to at or e raised to minus at multiplied by some function of t, then you have to apply FST, that is first shifting theorem. So according to first shifting theorem, what you have to do, you have to find out the Laplace transform of f of t, and in that function of s you have to replace s by s plus 3 if f of t is multiplied by e raised to minus 3t, and if f of t is multiplied by e raised to 3t, then you have to replace s by s minus 3, right? So in this problem, first of all, we will find out Laplace of 2 cos phi t minus 3 sin phi t. So 2 constant value as it is, Laplace of cos phi t minus 3 Laplace of sin phi t. And Laplace of cos phi t, that is s over s square plus a square, and a is 25, and 2 as it is, minus 3 as it is, and Laplace of sin phi t, that is a over s square plus a square, a is 5, so 5 over s square plus 25. Then after, you can see that in the denominator we have s square plus 25, so LCM is s square plus 25, so that will be as it is in the denominator, and in the numerator we will be having 2s minus 3 5 the 50. So this is the Laplace transform of this function of t, but we have to find out the Laplace transform of this function of t multiplied by e raised to minus 3t. So what we will do, we will apply the first shifting theorem, and in this result we have to replace s by s plus 3. So replacing s by s plus 3, 2 as it is, minus 15, and replacing s by s plus 3, the whole square will be as it is, plus 25. Now multiplying s plus 3 by 2, 2 into s, 2s, plus 2 3 is 6, minus 15. And in the denominator, applying the formula of a plus b whole square, that is a square plus 2ab plus b square. So it will become s square plus 2 3 is 6x plus 3 square is 9, and plus 25. Then after 2s as it is, plus 6 minus 15, the result is minus 9, s square plus 6s as it is, and 9 plus 25, that is 34. So this is the Laplace transform of e raised to minus 3t into bracket 2 cos phi t minus 3 sin phi t. Okay, now we will see second example. We have to find out the Laplace transform of t plus 1 the whole square e raised to 1t. So first of all, what we will do, we will find out the Laplace transform of t plus 1 the whole square, and in that function of s we will replace s by s minus 1. So first of all, Laplace of t plus 1 the whole square, applying the formula of a plus b whole square, that is a square plus 2ab plus b square. So it will become t square plus 2 1 are 2 into t, 2t plus 1 square is 1. Now applying the Laplace transform, so it will become Laplace of t square plus 2 Laplace of t plus Laplace of 1. And Laplace of t square is 2 factorial over s cube plus 2 as it is Laplace of t raised to 1. Answer is 1 factorial over s square plus Laplace of 1 is 1 over s. So Laplace of t plus 1 the whole square, answer is 2 by s cube plus 1 factorial is 1, 1 into 2, result is 2 divided by s square plus 1 over s. Now by first shifting theorem, Laplace of t plus 1 the whole square e raised to 1t, what we have to do in this function, we have to replace s by s minus 1. So the result is 2 by s minus 1 the whole cube plus 2 over s minus 1 the whole square plus 1 over s minus 1. So this is the final answer of Laplace transform of t plus 1 the whole square into e raised to 1t. Now we will see example number 3. We have to find out the Laplace transform of e raised to 2t sine square 1t. Now again we will apply FST to find out the Laplace transform of this function. First of all, we will find out Laplace transform of sine square t, and then after we will replace s by s minus 2. And Laplace of sine square t, applying the formula of sine square t, that is 1 minus cos 2t by 2. Half is a constant value, that will be as it is, Laplace of 1 minus Laplace of cos 2t, half as it is, and Laplace of 1 is 1 over s minus Laplace of cos 2t, answer is s over s square plus 2 square, and 2 square is 4. Now finding the LCM of s and s square plus 4, that will be s into s square plus 4 in the denominator, multiplying 1 by s square plus 4, result is s square plus 4, and after minus s into s square, and this half as it is, plus s square and minus s square will cancel out, divide 4 by 2, result is 2 over s into bracket s square plus 4. Now we will apply first shifting theorem. So what we have to do in this result, we have to replace s by s minus 2. So 2 as it is, replacing s by s minus 2, and over here replacing s by s minus 2 the whole square plus 4, s minus 2 as it is, this 2 as it is, and we will apply the formula of a minus b whole square over here. So that is a square minus 2ab plus b square. So it will become s square minus 2 2s are 4s plus 2 square is 4 and 4 plus 4 8. So this is the final Laplace transform of e raised to 2t sine square t. Now we will see third property, that is second shifting theorem. What is second shifting theorem? If Laplace of ft is f of s and g of t, that is function of t minus a when t is greater than a, and g of t is 0 when t less than a, then Laplace transform of g of t, that will be e raised to minus as into f of s. This is second shifting theorem. So first of all we will see the proof of second shifting theorem. First of all, we will apply the fundamental definition of Laplace transform, that is Laplace of ft, that is integration from 0 to infinite e raised to minus st f of t dt. So we will find out Laplace transform of g of t. So replacing f of t by g of t, we have Laplace of g of t, that is equals to integration from 0 to infinite e raised to minus st, replacing f of t by g of t dt. Now g of t function is defined for t greater than a and t less than a. So we will apply the break at point a. So for t less than a, g of t is 0. So we will apply the break at point a. So it will become integration from 0 to a e raised to minus st, and for t less than a, g of t is 0, 0 dt, plus integration from a to infinite e raised to minus st, and for t greater than a, g of t is f of t minus a dt. So here is 0, so this whole integration will become 0. Now we will solve this integration only. Now to solve this integration, we will suppose t minus a equals to x. Now differentiating this equation, we have dt minus, this is a constant value, so its derivative will be 0, and that is equals to dx. So we will replace dt by dx when t equals to a. So a minus a is 0, the value of x is 0. When t is infinite, so infinite minus a, answer is infinite, so x will become infinite. Now this integration will become integration from 0 to infinite e raised to minus s, and t, that will become x plus a or a plus x, and function of t minus a is x and dt is dx. Now it will become e raised to minus sa minus sx. So separating e raised to minus sa and e raised to minus sx, it will become e raised to minus as into e raised to minus sx. Integration from 0 to infinite will be as it is. Function of x dx will be as it is. Now in this integration, we will just replace x by t. So it will become integration from 0 to infinite e raised to minus st ft dt, and integration from 0 to infinite e raised to minus st ft dt, that is nothing but Laplace of ft, and Laplace of ft is f of s, and this e raised to minus as is f of s. So we have Laplace of g of t, that is e raised to minus as into f of s. This is second shifting theorem. Now we will see one example related to this topic. We have to find out the Laplace transform of g of t, and that is sine of t minus pi by 4 when t is greater than pi by 4, and g of t is 0 when t is less than pi by 4. Over here we have been given g of t equals to sine of t minus pi by 4. Now compare this function with f of t minus a. So f of t minus a, that is sine of t minus pi by 4, where the value of a is pi by 4. So f of t minus a is sine of t minus a. So f of t is what? Sine t, where we have taken a equals to pi by 4. Now we have f of t equals to sine t. So Laplace of f of t, that will be Laplace of sine t. And Laplace of sine t, that is 1 over s square plus 1. And Laplace of f of t, that is nothing but f of s. So we have f of s equals to 1 over s square plus 1. So this is f of s only, but we have to find out Laplace transform of g of t. And g of t is sine of t minus pi by 4 when t is greater than pi by 4, and it is 0 when t less than pi by 4. So what we will do, we will apply the second shifting theorem. So according to second shifting theorem, we have Laplace of g of t equals to e raised to minus as fs. And the value of a we have taken over here, that is pi by 4. So just replacing a by pi by 4 as it is and minus as it is. So it will become e raised to minus pi by 4 s, and f of s is 1 over s square plus 1. Okay. Thank you for watching this video.